All right, ladies and gentlemen. So I wanted to talk about a couple things before we go ahead and get into our demo problems for demos for our 2D forces. And we'll get to those in just a second. I do want to talk about in your announcement today, you should have seen that there's also this thing called an assignment checklist. So if you're planning on retaking any tests before the end of the semester, you have until the 13th to retake your tests, not the 13th today, the 13th of December. Should probably clarify that. So you have till like the 13th of December to retake any of your tests. And then for that retake, you do need to have all your assignments done. So on Canvas, there's a checklist for each of your assignments for each of our units that you are required. So there's a checklist for kinematics, a checklist for graphing, and a checklist for this unit for forces, which we're not done with. So you don't know if you have to retake this test or not. But then the last thing there is a lab retest, and it can replace your 2 kinematics labs or your 1 graphing lab. So it can replace one of those 2 sets, all of your kinematics labs, because each one had different standards, or our graphing lab, which had all of the standards. And in order to retake that test, you do have to have all of your assignments for the entire semester complete, which is why I'm telling you guys this now. That way you have, I mean, we have what, 4 weeks left until the 13th. So like 4 weeks before master exams, you have like 3 or 4 weeks to get all this stuff done and complete your retest for your lab if you choose to. And so if you're choosing to do that retake, what's going to happen is you're going to turn it in, and then you're also going to let me know which lab you're choosing for it to be a retake. So you can tell me, I want this to be my kinematics retake lab, or I want this to be my Galileo's ramp retake lab. So it's your choice what you want. It doesn't matter to me. Whichever one's going to help your grade the most, that's what you're going to choose. So if you're trying to go through that checklist and you don't know all your assignments that are complete, I do keep a pretty extensive list of all the assignments. I try and keep track of them as you guys turn them in and make sure that I keep them up to date so we can go through it together. And then if you notice that I'm off on something, then you can be like, oh, can you double check? Because I thought I turned this in, and we can go through that together. Any questions on that? All right, then what we are going to do today is we are going to go through 2D forces. So when we're talking about 2D forces, what I'm really saying is that there is some angle. And so we're going to have to do that components in the X and the Y direction. So in this case, there's our angle is upwards at 15 degrees. So we are going to have something moving, and it's going to have that angle. The other thing I want you guys to notice before we continue is this equation. I think it was on your other sheet before, but this equation right here is going to come into play because our force of friction right here is equal to mu. This is going to be mu times the normal force. This mu is really our coefficient of friction. So it's the coefficient of friction. So the closer you are, the larger the number is, the more that the friction is going to be applied to that object. So the smaller number means a smaller amount of friction. So when we solve for this later, which we will in the future, you're going to actually solve for that coefficient of friction to see how much friction is actually on that surface. The first thing it does say for us to do is to draw that free body diagram, which is going to be our case every single time. So let's read the problem. It says a child is pulling a 34 kilogram sled at a constant velocity by a string angled upwards at 15 degrees with a force of 84 newtons. So let's draw our free body diagram, and let's see if we can identify any information from that statement. So can anybody tell me a force that they would know is acting on that object?
Gravity.
Gravity.
Beautiful. Gravity.
Tension.
Tension. And which way is tension going?
15 degrees upwards.
15 degrees upwards. So am I going to draw it up here? Am I drawing it over here with an angle upwards? What do we think?
Angle upwards.
Angle upwards, perfect. So we're going to draw it over here with an angle upwards. And that angle, I'm just going to label it now, is going to be 15 degrees. And that's our tension force. Any other forces?
String.
What force?
Oh wait, never mind, never mind.
Oh, okay. Let me give you a hint. There's two more.
Would applied be?
So our applied force is really going to be the same as this tension force because we're applying the force to that string to pull the object. So those are going to be the exact same in this case. So we can change it if you want, or you can leave it as tension. It's up to you.
Normal.
The normal force, in which way is the normal force going?
Up.
Up, perfect. It's going perpendicular to our gravity or to our surface.
Friction.
Friction, which way is friction going?
To the left.
To the left, because it's going opposite of our motion. All right. Any questions on any of those forces? So then I want you guys to notice something. So if we're looking at the sum of our forces, so let's look at the sum of our forces in the x direction, and then the sum of our forces in the y direction. Can you guys tell me what forces do you see acting in the x direction?
It seems
Tension
to
and
be only
friction.
friction.
All right, I heard tension and friction. Diana, what'd you say?
I just said friction
You just,
because
okay.
tension is going in the y direction too.
All right. So, all right. I like both of those statements. So tension and friction, but tension is also going in that y direction. So what do you think we're going to have to do?
Set it up as both x and y.
Exactly. So we're going to have both the x and the y directions. So we're going to have to set it up with our right triangle with the sum of our forces. I'm just gonna leave it like this. All right. So we have our force of tension in the y direction and our force of tension in the x direction. So now, can you be more specific about which forces are acting in the y direction? Or sorry, in the x direction.
ftx. Do we just say like, okay, f when tension is an x, then friction?
All right. And are we going to add those two values together, or are we subtracting those two?
Subtracting.
All right. All right. So we have those two forces acting in the x direction. And then what about the y direction?
Would it be gravity? Oh wait, no. Tension y.
Mm-hmm. So you have tension in the y direction. What else do we have?
Normal force and gravity.
Normal force and gravity. All right. So now we have to talk about the direction of each. Are they going to be positives or negatives? Are we adding them or subtracting them? If we're adding them, they're going up. If we're subtracting them, they're going down.
Ft, y, and fn, we out them and then subtract them for fg.
Awesome. Perfect. Any questions so far? Is it making a little bit of sense? All right. So now let's read through that problem and we're going to pull out one more piece of information. So it says, or a couple more pieces of information. It says that a child is pulling a 34 kilogram sled. So I'm actually going to label this object as 34 kilograms just so I can remember it for later. And then we have that angle, and it says at a constant velocity by a string up at an angle upwards at 15 degrees with a force of 84 newtons. So that 84 newtons is what value? Which of our forces?
FT.
FT, our tension force, is 84 newtons. Perfect. My last question is this constant velocity, what does that mean?
Acceleration 0.
Acceleration is 0, which means that the sum of our forces, what do our sum of each of our forces have to equal?
0.
They both equal 0 because our acceleration for the sum of our forces is 0, which means each in the sum of our forces in the x direction 0 and the sum of our forces in the y direction is 0. Because there's no acceleration. All right, so this does help us find each of our forces, which is what we're supposed to do next, which is solve for each of our forces. So do we want to solve for each of them in the x direction or the y direction first?
X first.
All right, x first. So we have FTX and we have our tension force in the x direction, we have friction force. So one of these we can solve for without this sum of our forces, and it's going to be that tension force right here. Because we know what FT is, because FT equaled 84 newtons. How are we going to find our FT in the x direction?
SOHCAHTOA.
SOHCAHTOA. So what trig function, there we go. What trig function are we going to use?
Sine of 15.
Sine of 15, which is, if we're using SOHCAHTOA, is the opposite or adjacent over hypotenuse?
Opposite over hypotenuse.
All right, so opposite over hypotenuse. So it's FTY over FT equals sine of 15. So how do I get FTY by itself?
Multiply by
Sorry, go on.
84.
Perfect. You multiply by the FT, which is 84. So we can replace it first. So FTY over 84 equals sine of 15. And then we multiply it by the 84 to get FTY by itself equals 84 sine of 15. And then we can solve for this value and we get what as our answer?
$21.74.
All right, and where are we rounding to for this one? How many sig figs?
22.
22, perfect. All right. So now we solve for FTY. How do I get FTX then?
Cosine of 15.
Exactly. So I have FT in the x direction over my force of tension equals cosine of 15.
Could you do a squared b squared is equal to c squared?
You could also solve it with a squared plus b squared equals c squared, because at that point you have this one and you have this one. So you can solve it using a squared plus b squared equals c squared. This one, either way, should get you the exact same answer. So for this one, if we replace it with our 84. All right, how am I going to get my force of tension in the x direction by itself?
Multiply 84.
Multiply by 84. And what do I get for my force of tension in the x direction?
81.
Any questions on solving for those two forces? All right, so then we're going to go back to this lovely equation and we're going to set it up now. So can I get my force of friction by itself in this equation?
No.
We can't?
Can we just add it to 0?
All right, so let's just add it to the other side. So I have my force of tension in the x direction equals force of friction. So now can you solve for your force of friction?
Yes.
What do you get?
The same thing as FTX. Sorry, I didn't write it down.
You're good. The same thing as FTX. So we get our 81 newtons. Are there any questions on how we got that? Are there any more forces in the x direction we need to solve for?
No.
Nope. So now we can go to our y direction. And so there were 3 forces in the y direction. We have our force of tension in the y direction, which we already know because we solved for this earlier. We have our normal force and we have our force of gravity. Are either of those two values things we can solve for without doing any without using this equation?
Force of gravity?
The force of gravity. And how do we solve for the force of gravity?
Isn't it the mass times the acceleration due to gravity, or no?
Perfect. Mass times the acceleration due to gravity. So if we're finding the weight or the force of gravity, we have mass, which was what value?
34.
34 kilograms, times our acceleration due to gravity, which is what value?
Negative 9.81.
Perfect. All right, so what do we get for our force of gravity?
$330.
330, perfect. All right, and so I got rid of that negative part because the negative is telling us the direction and we already have our negative up here, which means we don't have to include the negative down here. So it's either you include your negatives in your accelerations because they're negative accelerations or telling us that direction, or you include the negative in your original equation and then you don't have to worry about your negatives in your values. So this is just our magnitude of the weight, not the direction. The direction is already up here. All right, so now we have these two values. Can we solve for the normal force using our equation?
Yeah.
All right, so what are we going to do first?
Replace FTY with the value that we got before,
All right,
and then subtract it by F of gravity.
all right. What's next?
Then we solve for that and pass it to the other side.
All right, so if we add those together, we get the normal force minus 308 equals 0. So what does my normal force equal?
308.
And then with sig figs, what does my normal force equal?
310.
310, perfect. Any questions so far? on how we found any of our forces. Are there any forces left we need to solve for?
No.
No, so we're done with part B. Now part C, our wonderful part C says, what is the coefficient of friction between the sled rails and the ground? So for part C, we need to use that new equation up here. The force of friction equals mu times the normal force. All right. And so can we solve for mu? Can we solve for our force of friction?
Yeah, because we know the friction, force of friction, force of normal.
Perfect. We have our other two values. So our force of friction we had was 81 newtons equals mu times our normal force, which we have was 310 newtons. So how am I going to get mu by itself?
Divide by
81.
310.
What do we get for mu then?
0.26.
Perfect. And there are no units on mu. It's a coefficient. It has no units that go after it. So this is our final answer. Are there any questions on anything we just went over?
Why does constant velocity mean that there's zero friction?
Uh,
I mean, zero force.
Okay, so constant velocity means no acceleration. So if we were to do the sum of our forces equals mass times acceleration, but when this is 0, we have the sum of our forces equals mass times 0, which means the sum of our forces equals 0.
Okay.
Any other questions on anything we went over today? All right, then there's one last thing I wanted to talk about real quick, and that is that there's two types of friction. Two types of friction. There's static and there's kinetic. Do you guys have a guess as to what either of those two are?
One's moving and one's not.
Exactly. So one of them, the object is moving and there's something trying to slow it down. The other one, the object's not moving, but there's a force being applied, but the friction is too strong. And so that force isn't, the force of friction is holding it still. So static friction is when the object is not moving. But there's friction present. Kinetic friction, because kinetic, we'll talk about later, is about movement of particles or objects. So the object is moving. And so static friction means friction is holding it still. And kinetic friction means that the friction is trying to slow it down. And this will come up on the homework, which is why I wanted to bring it up before you guys got to the homework tomorrow, or not tomorrow, Monday, and you guys got confused on it. Anything else? All right, that's all I have for you guys today. So if you guys wanted to start your homework too, you have 15 minutes left of class. Otherwise, you guys are done for the day. And have a great